So most of the commercially available algorithms is for the tuned best for the prediction, not for our association studies. But that is not an issue. Now, so now we will be discussing about how we select the variables that is to be. I told you it is very easy to come up with the result. We have SPSS, we have Jamovi. If we have time, we will demonstrate how to put it in the Jamovi. It's very simple. We put that variables in the corresponding columns, you come out the results. You just need to know how to interpret. But the fundamental question is not putting the variable. Which variables you will put it in the equation? That is the most important thing. That is different with respect to association studies and prediction. So the most important thing when it comes to logistic regression is these four things. This is called the variable selection, model specification, model fitting, and model selection. So how do you select the variables? One second, please. So how do you select the variables? We'll come to that. So variable selection. How do you select the variables? Any idea? Anybody? Anybody, any idea? Hello?
From the clinical knowledge of the condition, is that?
Yes. That is very important. Variable selection, you come up with a priori knowledge. There are two approaches. One approach is theoretical foundation. Second one is algorithmic approach. You people know both these things. Algorithmic approach we will come to. First, theoretical knowledge. But we should be concentrating only on the theoretical approach because at present, most of the field are well developed. So at least some knowledge we can have from the literature. So a thorough literature review. From the literature, you come up with the possible variables. This is the first step. This variable identification, the most important step. Second, you know from the variables, what are these variables available in our situation? And there could be a lot of, suppose there could be a lot of missing. Suppose you are not doing a prospective study, you are taking a you are trying to use some database. There could be some variables could be having a lot of missing values. So missing values, you omit that variables. So these are the foundational steps when it comes to variable selection. Literature, experience. These are the three things very important when it comes to the variable selection in association studies, and there is a question. But in prediction studies, another thing is also very important. Is it available at that point of prediction? If it is not, suppose in your scenario, a particular biomarker is not done, and the equation you developed by somebody else containing a particular biomarker, is it applicable in your scenario? So in that prediction scenario, the availability of the variable at your center and whether it is cost effective, these are also other factors we take into consideration when we select the variables in a prediction question, like developing a prediction model for mortality in burns. So in that scenario, that availability of the variable is very important, and the cost effectiveness of the variable is investigation is also very important. So in association studies, we initially previously we went in for algorithmic selection. That means variables based on p-values or some other statistical criteria. Nowadays, it is the variable selection is based on theoretical knowledge rather than algorithmic selection or p-value selection or change in estimate selection. So variable selection is very important. This is very, very important. We should sink in, because what we usually do is we have a question, not prediction question. We have a association question. What are the risk factors associated, or this particular risk factor is associated with a lung carcinoma, whether smoking associated lung carcinoma. We find out, we do the literature search, and we have a lot of variables, or from the experience, or from peer review, or from discussion in conferences, discussion with colleagues, we have a lot of variables. Now, in the classical way, what we do is we do some p-value hunting. Like, we do an association, we find association between death, smoking, and age. Then we do find association between this and this. So we do univariate. This is called so-called univariate analysis. We do some kind of 5 or 6 or 7 univariate analysis, and we come up with a p-value. Then, if the p-value, based on the p-value could be classically started with 0.05. Then for the variable selection, they came down to 0.1 and to 0.1, 0.15, 0.2. Still, it is not correct. Variable selection based on univariate selection is not at all correct in the association studies. What happens there is, actually, you would have omitted a lot of variables. That's called the omitted variable bias. Another issue is called the estimation bias. Because what happens, in the data you have, only the association may be present. The actual scenario in the population, the association may not be there. And another thing, you are losing your cash. That means you are spending your money. You are spending the power, or you are inflating the error. That is one of the. So we can think of this. So there are 5 variables. Then the p-value is almost like a 0.05 divided by 5. You have to correct it, but we don't correct it, because it is like spending the cash. You are actually inflating the error. So this kind of estimation bias occurs when you go for that univariate selection. So never go for univariate selection unless some stupid reviewer asks for that. That is a statistical aspect. Now, model specification. What is a model specification? Anybody? Anybody? Hello?
Not sure about it, actually. Yeah.
This is one of the important thing. We all know that what is model specification. We will come to that. We already identified 5 variables. Imagine, for the carcinoma lung, the research question was carcinoma lung was smoking, whether smoking leads to carcinoma lung, or whether smoking is associated with carcinoma. This was the research question. We found out 4 more variables. So we have 5 variables in total. 5 variables we have in total. Okay, 5 variables. 5 variables you have in total. So 5 independent variables we have, or predictors we have. Now, sometimes if you go on doing some literature, so you will come up with a lot of other variables. How many variables you put it in the software? That you can imagine the model specification as like that. How x1, x2, x3, x4, x5, x6, x7, or you stop here, or you stop this much, or you stop this much. This is called a model specific. That means you come up with a model. This model has to be pre-specified. This is also one of the fundamental principles when it comes to association studies. Models should be pre-specified. You can pre-specify one model with the 6, 7 variables, or another. You can specify one more model with the 6 or 5 variables, or like that. Is up to you, depending on the sample size you have. If you don't have that kind of sample size, you specify only one model. That means before even taking the software, you should have created a model in your mind. You should have decided these are the variables in my models. That is based on literature search, as well as your sample size and various other factors. This is called a model specification. Previously, model specification were based.
Dr. Yadav, I had sorry to interrupt.
Oh, time is running out. Okay.
I had this question about model. Deciding the model.
You're not audible.
Deciding the number of variables that we need to check for. Is it?
It is not that much. It is not that
so
alone.
I just wanted to ask, deciding the model specification, does it mean that you choose the number of variables study or that particular research question?
That is not alone. That is one of the one of the things that, one of the factors that goes into model specification. You will have to think about the interactions also. You have to think about whether I am going to put in an interacting term in the model, and the functional form also you have to think of. There are multiple things you have to think of when you plan the pre-specification of model. This is the first step. That means these are the variables I selected the variables. Now, in which functional form I will put the variables in my equation. That is also important. And what are the interactor or effect modifier I will put into my models. I will tell you how, why. Because you know that in some condition, okay, in a carcinoma lung, females, I don't know, I think male has got more predisposition for developing carcinoma lung, I think. I think so. Female doesn't have that much. Or the age group, in a particular age group, there may be more prediction for developing carcinoma lung. That is a theoretical knowledge. That means within the level of the age, the carcinoma lung occurring is not uniform. That means the probability of carcinoma lung occurring is non-uniform. That means that is a moderator or a moderating variable. Moderator. Okay. This is also known as a effect modifier. So from the theoretical knowledge, if you think that interaction is there, then you have to think of a product term also. Product term means in the equation, along with the x1, x2, x3, you will add one more. x1 into age x2 suppose the x2 is age, that product term, this is also you put. This is called interaction term. This should also be based on theoretical knowledge rather than statistical hunting. Is it correct? Is it clear for you? Dr. Bhakti? Dr. Bhakti?
Yes, yes.
That
Yes,
means
it is now.
we have selected a few variables, but from the theoretical knowledge, we know that this particular level, like a male has got more predilection to develop carcinoma lung rather than females. That means within the level of this sex, the association between smoking and carcinoma lung is not constant. That changes. That means there is an effect modification by sex. That means you have to put it as an interaction variable in the equation. There are other ways also by stratified analysis, but when it comes to logistic regression, we have to put that means how you put the whether you put the interaction variable also in the model, that is also come under the model specification. Another thing comes that I thought I will not be going to that, but as you asked, only I told you about the interaction type. Then another thing also actually go into the model specification, that is called the functional form. Sometimes, you know, it is not the x, the association, the biological association may not be in the form of x, it could be in the form of x square. That means the functional form will be something else. Or something it could be in the form of log x. That could be from the theoretical knowledge or from the literature. So sometimes when you model, the functional form is also important sometimes. But most often we limit ourselves, except in prediction studies, we limit more to interactions, putting interaction term as a product term and variables only. Is it clear till now?
Yes, sir. Yeah, Dev, it's very clear so far.
Yes, it is. Yes, it is now.
So that is called the model specification. Previously, people thought that the model specification that you do after the variable hunting with the p-value or some other fantastic statistical measures. No, it is not like that. Model specification that should occur before your yes, Dr. Anita, ma'am, you
Yeah,
please ask.
just
Yes,
one
ma'am.
question. Just one question from my side about variable selection. As we said, theoretical knowledge about the condition would be one prerequisite to find out what all can affect the outcome variable. But is it necessary to have a univariate analysis first and then select the variables based on that, whatever comes significant or whatever shows association, and then you put those variables in the logistic regression? Is that mandatory, or based on your our understanding of the subject we can put it over?
Actually, this variable selection based on univariate analysis is not recommended at all. But people still prefer that in some parlance. Sometimes
Yeah,
it
that
makes
is
very
why, because
difficult. Sometimes,
many papers mention that. That
yeah,
is why I
yeah.
asked. Thank
One
Yeah,
of the
thank you.
issues with the univariate analysis is each analysis you are spending p-values. Okay, each analysis is spending the power. That means you are inflating the errors. So actually, if you are doing univariate analysis, you should have enormous sample size. That means one time you do an analysis, one look at the data, that means you are spending on p-value. That means if you have looked at twice, that means you have to do the Bonferroni correction or some fantastic correction to get the actual thing. That means 5 variables are, you did the univariate analysis 5 times. That means you should have taken the actual p-value when you do the analysis should be 0.05 divided by 5, at least Bonferroni correction. But even after the correction, after the univariate analysis, what you get is not the correct value. You will get the inflated beta and you will get the deflated p-value in the model output. So that is one of the issues with the univariate analysis. But that is still going on in parlance, because the SPSS started with it was with the SPSS that people started. That also bringing into the concept of the prediction concept in the logistic regression to the association studies is still rampant. So the dictum is the correct method is not that one. We try to model, we try to do variable selection based on theoretical knowledge and etc. And try to model, pre-specify the model. And if your everything is for publication now. If the reviewer is not okay with that, then we will have to revise. No other way. Okay. So model specification.
Dr.
Now,
Yadav, sorry to interrupt, Dr. Yadav. We have about 5 minutes or so in the meeting, so we will need to,
I'll write
so
for
that we can have some question answers if at all some are pending.
Okay,
Thank
I
you.
will write through. So now you specify the model. Now comes the model fitting. Here you actually put it in the model, and you have that line, the S-shaped line coming. You can imagine that way, but you will come up with some result, that model output. When you have the model output, then you interpret the result. This is the interpretation is different for association studies and prediction. Prediction is not the interpretation that is important. The prediction studies, the formula you create, you come up with is the most important thing. There, the probability of the new patient, probability of disease occurring in a new patient, that is not in the data, that is important in a prediction. In association study, it is the exact beta you need to have. This is one of the issues when you do the univariate selection. The beta you got would have been inflated beta. So you would have come with a very good result, very good effect size. Actually, it is not there. That is one of the issues with the univariate selection. Another issue. Estimation bias is another issue. So model fitting, there are some model fitting tests there. We are not going to that. Then there is model selection. Why model selection? Because if you have pre-specified 2 models, sometimes you'd have read such a model, 2 or 3 model specification when it comes to prediction studies. If you have specified multiple models, then you need to select on. The concept is the least complex model is the best model. The question here is actually what you call this compromise between interpretability and complexity. So model selection is based on some various factors. One of the factors you can adopt is likelihood ratio test. Other thing is AIC, alkaline information factors. This model selection may not be coming to association studies much, but nowadays new studies they report multiple models also. Now, sorry. Sorry. Can you see that? Can you see my screen?
Yes.
Yes, yes, it is.
Okay, then we'll just try to. Actually, the model fitting, there are some basic differences. This is a theory only, basic difference between linear regression. There it is the least, we use the least square method. Here it is not the OLS method, is also known as OLS method. But in model fitting and logistic regression, what we do is something else called the maximum likelihood estimation. We estimate the likelihood estimation for multiple times, and we go for the maximum likelihood estimation. This is what we do for to determine the optimal set of coefficients. Then interpretation. These are the results you get in the output. First result you get the coefficient in the coefficient. If your study is a association study, it is a coefficient that is important, but you take the exponentiation of the coefficient. That's a e raised to beta. You take it's a odds ratio. That is odds. That's what you go for interpretation. Then the standard error, that means that precision thing. Based upon the, you calculate the confidence interval. If it is a statis, also known as a wall statis, is actually that is found out from dividing the first thing divided by the standard error. Then p-value, based on the t-statis, you calculate the p-value. This p-value is for the significance of the individual predictors rather than for the model. Model, it is from the model fit. Now, interpretation. So, most of the studies are association studies. Okay, most of the studies we encounter is association. Nowadays, only the prediction things are comes up. So, the interpretation of the beta and the actual beta should be there. So, it should not be inflated beta. So, that comes the importance of all these model specification, variable selection, etc. Here, how do you interpret the odds ratio? Most of you know that 0 means no associated effect. 1 means odds of outcome. Never use probability. Use the odds of outcome with increasing variable values. With x, with every x unit increase in the x, with every unit increase in the x, the odds of outcome. You term that way. How much is the odds of outcome? That is the interpretation when you use the odds ratio. One more sentence is one more adjective is important. Adding is important. Keeping all other variable constant. This is how you interpret an odds ratio. Less than 1 means odds of decrease odds of outcome, but you can divide -1 and report the opposite thing. So this is a standard output from a regression output. You look at the p-values. Then from the p-values, these things are significant or not. What is significant? That effect size is you got the odds ratio, that is significant or not. Sometimes the odds ratio may be very high, but that may not be significant. In that scenario, you won't take that. Then interpreting the odds ratio, suppose 0.05 coefficient implies. What does it implicate? The implication is there are two ways. You can just convert this to e raised to beta, e raised to 0.05 and interpret as a odds, or you can interpret it as log odds of developing heart disease increases by 0.05, or the same thing. 0.05 converted into e raised to 0.05 is odds ratio of 1.5 means the odds of heart disease increases by adult by 5%. So if it is a continuous value, instead of every year rise in age, it is better 10 year or 5 year like that. You can calculate with 5 year change, 10 year change and report. That will be more interpretable or more useful rather than every increase in 30 years. This could be the probability, and 50 years this could, or 10 change in 10 years increases this much. That will be more useful when it comes to interpretation. And when it comes to dichotomous variables, you keep one variable as a base variable, the reference value, and compared to that, you interpret the other things. So there also actual, it is 0 compared to 0, 1. The same thing actually happens, but we say compared to females, males have this much. That is the interpretation for a dichotomous variables. I'm just rushing through. So we have already discussed about the association studies. Then we discussed about the logistic regression. In prediction studies, there are something else also, a very important thing. So far, we discussed about various, what do you call this, model fit things and other interpretation of odds ratio, etc. In prediction, it is not the interpretation of odds ratio that is important. You don't even have to mention about the odds ratio in a prediction table. But many of the studies erroneously report this odds ratio also. There, the beta is important. The actual value of beta as such is not that important. It's a combination of beta 0 plus beta 1, actual value of the beta 1 in that equation is more important. It's a joint equation that is more important. So you are not going to interpret the beta there in a prediction study. That could be wrong because we are more concerned with the equation. There, what we need is actually the probability of a particular disease occurring in a new patient. Here, some new performance measures have to be reported. Those are called AUROC. AUROC means is also known as there is some other name for that. I just forgot it. So ROC and AUC is very important when you interpret the discrimination value. There the terms are discrimination and calibration. These terms are very important. That is to be reported in a prediction study using logistic regression. And you are not supposed to report ROC and AUC in a normal association study, because that doesn't mean anything at all. And calibration also you need to mention. Hosmer-Lame test can be used for, there is a model test that can be used for the calibration, but better is calibration plot, calibration the large, calibration the small, etc. This is very important prediction studies. Another important thing in prediction study is the internal validation. There are 3 types of internal validation. I will not go into that. The bootstrap validation is, and cross validation is at preferred at present. The 80 divided plus 80 cut training data into validation data is not preferred at present, except in machine learning. I think I will stop here. There are a lot of other slides, but we'll stop here. So we just discussed about, I'll stop the screen sharing. We just discussed about the fundamentals of logistic regression, touching up a small part. We touched upon the equations and maths just only. Then we discussed about the how to model that, how to pre-specify, how to do all those things, and we discussed interpretation also. We discussed. I still believe it is always better statistics should be taught by. I had an article in Medium. Statistics can go wrong if it is taught by a non-statistician. Okay. There's any questions? I think we have overshot the time. Sorry.
No worries, Dr. Yadav. This has been a very difficult topic. So I mean, you made your best effort to make it understandable, and that was really commendable. Thank you for that.
We could have demonstrated
And
that in
as
Jamovi.
Bhakti writes,
Yes.
understanding the ROC and AUROC will need another session, but we will have another session from you with more clinical examples. Over to you, Priyansh.
Just to add, hi, this is Dr. Kapil. Just to add, to understand logistic regression, I think first, most of people should understand the linear regression. If you understand the linear regression, then it's easier to understand logistic because it requires some minor modification. But if you understand all this, the model, the steps remain the same. You choose the variables. How do you choose the variables? How do you actually look for model fitting? How do you select the models? How do you calibrate the models? The steps remain the same, but linear regression is much easier for novices to understand. And once you understand linear regression, then with certain slight modification and certain extra concepts, the logistic regression would become much more easier to understand. Over.
Thank you so much, Dr. Kapil. I completely echo the baby steps to be taken over here, and lots of takeaways into this session. Basic things like independent variable versus dependent variables, association versus causation, and also the steps of making the model as well. So I personally have been, I'm a non-statistician myself as well, and it has been a great complex topic, which has been my confusion for a while. And this actually boosts me to start off with some study which has some of these learnings, and linear regression followed by logistical regression, something which we can definitely look forward to. We have been using univariate analysis ourselves as well, but now that's a great learning to understand that is quite redundant to approach to the next steps. So I will not take much time, but this thing is the best way to remember and make use of these regression models is to get into a startup study itself and revisit the notes and recordings of the sessions to go baby step wise. And I believe I'm looking forward to do it myself as well. So thank you so much, Dr. Yadav. There have been a lot of questions midway as well, which came in. A lot of questions will come up in the eventual sessions as well. So we will be looking forward to perhaps some questions over the emails if someone has a questions, or someone wants to reach out to, if they can reach out to you. Would that be convenient, Dr. Yadav?
Sure.
Thank you so much, Dr. Yadav. This is invaluable indeed. And we will also be using the Jamovi, which you suggested. This is a very new platform for myself. I just looked up into it. So thank you so much for sharing those midway, some new tools as well. So lots of information to process, but baby steps first. Looking forward to start off with some ideas.
There are some modules in Jamovi so that you can just come out with the actual tables also.
That's very fascinating to know, actually. That saves a lot, may save a lot of time actually to develop those tables. So as of now, we will be looking forward to using the notes and what I have created some, and perhaps everyone must have taken some key takeaways as well. So thank you so much, Dr. Yadav, for your time. And we will be looking forward to the next session in the next week itself on quality improvement, the next cycle as we are working on. And as of now, we'll request the people who are on the call to perhaps just take a minute and just fill the feedback session form as shared in the chat box. And please feel free to join our WhatsApp group. We usually post our latest updates over there. And surely, if anyone has any questions, we'll definitely look forward to take them up and reach out to connect you with Dr. Yadav for making the logistical regression model happen and demystifying, which has been demystified to a lot extent in this session, but lots to look forward to. Thank you so much for joining the call. I'll just hold for the next 10 seconds for the last burning feedback or comments before we close the session. Over to audience. In case none. So thank you so much, everyone, for joining in. We look forward to working on some perhaps studies based on the logistical regression. So soon to see some outputs. Thank you so much for joining in.
Thank you so much. Thank you, Dr. Yadav.
Thank
Thank you,
you.
Priyansh.
Thank you,
Thank
Dr.
you.
Yadav.
Bye-bye.
Thanks,
Dr. Yadav.
Priyansh.
Okay. Bye. See you next week.